Okay, hello. I am Ankita. I'm trying to share my slide. I think the slides need to be brought up. There you go. Okay. Hello, my name is Ankita. I am an Angular GDE. You can find me on Twitter or LinkedIn. I have my handles on the slide. I am currently based out of Austin, Texas, and I work as a senior principal engineer with SecureWorks, which is a cybersecurity company. And we are a big team of Angular developers. We have uh, a lot of fun and a lot of data sharing amongst each other's components that needs to happen. The data needs to be passed around. So today, I would like to talk to you about um, how to share data. There's different use cases, and there's a way to share data for each one of them. So that's what all of this is about. Sharing data with the right use case in a responsible way. And let's get started. So, name of my presentation. The title of my presentation is Sharing is Caring. It's basically about responsibly sharing data amongst Angular components. There potentially four different categories into which communication between just two components can be broken down into. You could have a parent component trying to share data with a child component, or you could have the child component trying to share data with the parent component. And then you have something called routed components, which is basically the main component that loads for a given route. When you have a route configured, you'll mention which route is associated with which component, and that's what a routed component. So how do you share data with a routed component or within different routed components? And then there are unrelated components. They could be anywhere in the app. Um, they don't have a one-to-one relationship in the sense of they're not parent-child, they're not routed. So we just throw them under the category of unrelated components. If you were to look at this tree representation of a DOM structure of an app, you will typically have a body, and then also is that's the body tag, and then you will have your main app component inside which you would have a header. You would have the header might have like a top navigation, a logo, or side navigation, etc. And then inside the pages component you would have a hero image, or maybe a carousel image or something like that. And then you would have the main content component. The main content you might be displaying based on the route or something, a chart, a panel, a card, a grid, whatever you have to display. And so this is a typical structure of any app, not just an Angular app, that different sections can be broken down into different components. And in those different components, you can see that, okay, so the main content component over here is the child of pages component, and is the parent of a card or a panel component. And you'll be breaking down uh, whatever it is based on your needs, and the breaking down whatever data needs to be displayed based on your needs for the component. And that's how you will basically then be sharing data. So this is a parent child relationship, but a footer component is not really related to a header component. Like, sure, a chat component has no direct association with a logo component, right? So those would be your unrelated components. And then the routed component would just be the main component that loads for a given route again. Okay, So first, we'll look into different ways of sharing data between a parent to child component. The first way that I have for you is using content projection. Parent can use content projection almost like how every parent projects their hope and desires for the children around them. So, when you need a flexible, reusable component that can accommodate different types of content, you want to control the structure and styling of that content within child components template. This is what you would be using. The parent gets to have more control on the data and type of data, etc., that will be presented to the child. So you would use this typically to pass different types of dynamic content in a flexible, reusable way to the child. So here you can see that the main content component is the parent component, which inside which, oops, inside, my bad. Let me share again. Okay. Yeah, so we were in the previous slide. So here you can see the main content component is the parent component, inside which you have the card component as the child, and within it you are passing that you are content projecting the information, whatever you or whatever data that needs to be passed uh, within the child component. Anything that you pass, that's what gets content projection. So this is generally the most flexible way when you want to have a reusable child. So some other parent component can content project some other things in the child. You can also pass data from parent to child using inputs. Those are typically more, uh, passing through inputs is a more structured way of doing that. And you can have um, all all these uh, attributes already predefined that establishes a clear structured flow between the parent to child. So you would use this way to, like I said, to pass structured type safe data to the child. You have already defined the types, and all the child does is displays it in the way it is supposed to. So the styles for all of the data will be in the card component, which is the child here, and the parent is just using it to break itself down into simple modules and pass the component. Then you can pass from parent to child. You can have using outputs. Outputs are something that the child is giving to the parent, but it is again like parent to child transmission, and parents can handle events or interactions. It'll receive the information from the child, whatever. And so here you can see in this example, there's a card click output emitter that the child is then leveraging, that the parent is then leveraging the ID that is being passed. um, there are two childs here, actually, the app card and the app grid. So in this use case, what I'm trying to show is that uh, both of these child components can emit the ID of whatever info was being clicked, and then you can view that information in a panel. So all you need is the ID, and then you call this function view info in panel using the ID, and then you just open the panel and fetch the data based on the ID. So that's how the main component can handle multiple things like that. So again, you would use this way to subscribe for updates from the child if the child is trying to tell you something. This is what you would use to listen to it. Okay. Those were all the parent to child use cases. How would you share data from a child to parent? If you remember a few slides ago, we had this use case of wanting a reusable, flexible child component. And for that, we were leveraging content projection. So here on the slide is the same code that you saw previously, with the main content component being the parent and the card component being the child. Um, so just a refresher that this is what the parent would look like, but now let's see what the child will look like and how it would pass it. um, so the child would typically, as I had mentioned before, it acts like a container, and the parent different parents of the child can pass any type of content in it. So the ng content tag right here, that's the placeholder for the content, and it handles the presentation logic in child, where in the sense that the child, based on the select tag, the child determines, okay, if this is the information that is being sent to me from my parent, where would it get displayed? Additionally, it also handles um, information for where to display, but also when not to display. If something is not being passed, how to handle that. So I think it's a great use case. Um, One important thing to remember is that ng content element that you see over here, it's not a component, and it's not a DOM element. It's not valid HTML that you could use in any other framework. It is an Angular specific element, and it's a special placeholder that tells Angular where to render the content. So Angular's compiler processes all of the ng contents when it sees it at build time. You can't dynamically insert or remove that tag, and you cannot add directives or pipes or any other arbitrary attributes, because it's not an HTML tag. So the Angular compiler um, only has one way to read it and compile it and understand it. So it's a special tag in that ways. Okay, so now let's look at the parent with inputs again one more time. This is how the parents look like. This is what the parent looks like again. So here the main content component is passing title, description, and image properties to the child. And in the template, you can see the child is receiving them in square brackets. Um, these square brackets, for me, they look like gift boxes. So you can think of this as the way where the parent is passing a gift in a structured way. I think that helps you remember the use case for it. The square brackets in the parent's template indicate that we're binding, that this is the binding thing, this is the binding property to the child. Now let's see how the child receives that gift. um, this is what the in the child component, the inputs are marked using something that we call decorators, um, which makes sense, right? The parent is gifting the child an input property in square boxes, so it has decorators to make the gift look pretty. Um, they cannot be updated at runtime. Also, these are static values that get recorded from the parent. They can also be coupled with other component properties, like for example, they can be nested with host binding. Here I have a use case for that. Like if the input is error is that is of type boolean, if the is error is true, if the input property is true, then when you nest it with host binding, the error class gets applied to that component. So the child can receive all these input information and use it in multiple ways. So you would use this when in a child component you want to receive structured type safe data from a parent. Oh yeah, this is just me highlighting the input decorators. There is now another way. As of Angular v 17.1 version 17.1 onwards, you can now, instead of using decorators, accept signal inputs. So the parent passes to the child the exact same way. There's no different in the syntax the way the parent passes the information. It's just the child can, instead of accepting decorator values, can accept them as signal values. And since signal values are a reactive alternative to decorator based inputs, you can think of them as supercharged inputs because you can still do all the things that you can do with inputs, and you can use all the power of signal properties. You can use computed and effects and just have a more powerful way of handling that data. Now, there are numerous benefits of using signal inputs over decorator inputs, and it's really straightforward to replace one with the other. So, just a reminder that they're still in developer preview signal inputs, which typically means that the Angular team has marked this as something that is still not experimental, but something that they might change. There hasn't been a time where something that's been marked in developer preview has been deprecated. So it's not that this will go away. It's kind of like use with caution. It's not production ready. However, they're confident enough that you can start using it right now. So again, this is, you'll use this the same way how you would use input decorators. You'll capture values from parents in a reactive context, and that's the key difference. It's the same structured data, just it has reactivity embedded in it. Okay, now if we were to let's look at the parent component and what the output looks like when it's receiving an output. So this is again the same example that I had when we were looking from parent to child. You see, notice the round parentheses around the event name over here. That indicates in the parent template that we are binding to an event. Um, those are for the output events from the child. So here the parent is receiving an ID on the event that it's tracking. But we are now trying to understand the way the child will handle it. So let's look at the child. Okay, so for outputs, it's similar to inputs that you can have decorators around it. Um, they are what indicate that this is a decorator property when you add a decorator around it, and you would use this to notify parent about updates. And so we'd seen the parent earlier, and here the card component is the child, and the card click emits basically this event emitter which gets passed to the child, and it can be of any type. It can be of a primitive type or of any data structure type that you want to emit to the parent. Typically we use it for primitive types to share information with the parent. And if you were to convert this into signal, again, signal outputs are also in developer preview, but this is what the syntax would look like. They're also super easy to swap out. Instead of decorators, you just use the output signal. um, and they also emit values in the same way, so you do dot emit to emit the value in the same way. The only difference now is the type. Instead of event emitter, we now have something called the output emitter ref, which is more safe to use and correctly typed, and hence also the reason why we prefer using the output function. And it aligns well with the signals API. So you'd use this to notify parents about outputs by using a more consistent API and a simpler mental model. Okay, so sometimes both parent and child need to share data simultaneously. You want to be able to listen for events and update values as you go, like the and this is what in Angular is called is known as two-way data binding. The parent passes a value to the child component, the child modifies the value and passes the updated value back to the parent. All while, well, suppose the user interacts with the child component, or for whatever reason the value needs to be updated and the parent needs to know about the updated value. So this used to be a bit more complicated. The child would have to define the input property to get the value from the parent, and then define an output property to send a notification event for the same value to indicate that, hey, now it's updated. So uh, it this is what that would look like. The value is the input property in this date selected child component, and obviously the main component is the parent component here. So you can see that there's a value and then there's a value change, and that's how this has been the historic way of handling it, uh, using two-way data binding. And some of you might be familiar with the shorthand that I have over here. It was also known as this combination would be of square brackets and parentheses, was also coined as banana in the box. Um, you can see that basically it's the same thing. It's indicating to the parent that value is going to be the input, and because of the round brackets, it's also going to emit the change related to it. So yeah, this is what you would use this for, is to listen for events and update values simultaneously, between a parent and a child. But now with the latest version of Angular, it's become a little more easier to do that. In this slide, in the previous one, I had the example of what the main component would look like, and this is what the child component will look like. Like I mentioned, it'll have to pass or like using decorators. You would have an input and an output for the same property, and that's what establishes the two-way data binding. But starting version 17.2 again, we can use something called as a model input, and so you can swap out both your input and output decorators for a model signal input. And it basically does the same thing, that it establishes two-way data binding between the parent component and the child component. It's it's a special type of an input. The component writes new value into the model input, and Angular can propagate the new value back from the child that is binding to a value into the input. One thing to note here is that when we were looking at signal inputs, those were readable inputs, but the difference between those and model signal is that it is a writable signal. What that means is that its value can be changed from anywhere using the set and update methods that are associated with the signal. So its type, when you look at it, is a writable signal. So when a new value is assigned, the model signal will emit to emit the new value as an output. Another difference between input signal and model signal is that model signal does not support any input transformations. Basically, you will be using the value as it has been provided. You can't transform it into uppercase or some other type, how you could do with inputs. So yeah, you would use that to enable two-way data binding in a reactive way. Okay, so those were all just different ways of sharing data between a parent and a child. Now let's look at some routed components. Routed components, like I mentioned earlier, but as a refresher, they're simply components that are associated with a specific route in your application's routing configuration. Each routed component is linked to a defined path that you would have in your routing config. And if you can, there are multiple ways you can pass data with through the route, though it depends on how you configure it. So you can have something called route parameters. Here the id is the parameter uh, that is being passed for the route. And basically what we're saying is when the user navigates to you in the browser, the url is something like product slash some id, some number, some string or anything. This is the component. Product details component is the one that should be loaded. You can also pass query parameters, and that is typically it. In the browser URL, it shows up as ampersand question after the question mark. You can have multiple or even just one. There'll be something like some URL question mark, and the rest of the string uh, will, as a key value, would be the query parameters. Then you have route data or data property, which this is the route parameters right here. And apart from that, you can also part something called the data which the child can receive. And so here we are passing that for this route we want the title to be search, and you're passing it that ways. And then you can have a state property, and similar to data you can pass a complex data structure through the route. And honestly, all of these ways deserve their own presentation topic that they can really go in depth to them. I just have an example of how they can be used, but there's several other ways of configuring them even. So, but these are generally the ways that you would be using to pass different types of data to your components through routes. This is your route config, and just those different ways, like this is the path, so this is the query parameter, and then you have all the query parameters, the data, the state property, and yeah, you can do a lot of things. You can configure your routes in a very structured way and have the component load and get all the data associated with that route. For example, here, this search component, which is a routed component, you would get the ID. This is how you would read it in the component. If that I For a route that has been structured like this is how you would read it. You would, listen to the activated route, and each of them becomes a subscription, so we can access the query parameters, the path params, the data, the resolved data, and the state object through the route. And this is how you would be reading all of those values. um, as of Angular version 16, instead of having to inject the activated route, you can actually subscribe to the value. Instead of having to subscribe to the values using activated route, you can use inputs, the same inputs that we saw between parent and child. Now you can use them from a route also to get those values. And again, there were two types of inputs that we covered: decorator inputs and signal inputs, and you could use either actually in your app. um, so to enable this, what you would have to do is, either if you have a standalone app, you would have to add a with component input binding. And if you don't have a standalone app in your module, you just mention this property to be true wherever your router module configuration is. You just pass in bind to component inputs to be true, and you can still use them as inputs. So instead of all the lengthy injecting the activated route and all the lengthy subscriptions that we had seen a few slides ago, you just use inputs, and it just needs to be the same. Oops, it just needs to be the same value that was mentioned um, in the query parameter or the route parameter. It needs to be, ID needs to be the same type that is being passed, and you just get them as inputs. Or you could use aliases too and have a different name in the component. Okay, so the last one that I have for you are unrelated components. And honestly, okay, let's look at the tree again. So this is the DOM tree. And if you remember, we've covered like parent, child, and routed, and unrelated ones are something, for example, a grid component right here is not really related to the logo component all the way over here. There's no relationship that you can see. And that's what we are calling unrelated components. They can still share and consume data with each other. Um, and there are different ways of doing that. One example for this use case is like, suppose you have a weather service in the app that gives you weather based on the city where you're accessing the app. And then all the components in your app are, you have this app that need to be styled, all that needs to style all the components based on the actual weather. So if it's raining, all the components you have some raindrop animations. Or if it's sunny outside, you want to display sunglasses or have like sun shining and background images, and have some updates in updated component light. So um, you would want to change, maybe you want to change the language or the text that you're using in your component to be related to the weather. So there are plenty of reasons why all the unrelated components might still want to share data with each other. And so there are two main things. The main roles exist in the dependency injection system, which is what you will be using. You have the dependency injector provider and the consumer. So by making the servers injectable and you're providing it in root, which means that it is available app wide, which means that all the components in the app, no matter where they are, if they are consuming the service, they'll get one instance of it. So that's how they would share the property. Whatever this service is returning when they call its get weather data, that value is what will be shared across the app. So another way, and then there are again different ways of providing a dependency. The first way, by using provided in, is what is preferred because it enables tree shaking. And again, there's different ways that you can configure it, and they all can be their own topics of an hour long or at least a 30-minute long presentation. But for now, we're just going to look at how to consume them at a component level. So in a component, the weather service that we had looked at earlier, um, you would just inject it. And I know I have two components in the same file. Typically, you would have a different component, a different file for different components, but this was just to, for brevity, just to show how you would consume the service that was provided at root. So in your providers array, you would mention the service and then you would inject it. And this way, both these components will get their own instances of the data. Some other ways that are not really specific to Angular, uh, all the ways that we have seen so far are very Angular specific ways that the team has come up with sharing, like inputs and outputs, and sharing between routed components and all the services. They're still in any application, no matter what framework you're using. There's still some other ways that you can be leveraging to share data that are just web specific, that the web platform, as a result of the web platform. You can use the local storage or the session storage. You can have some state management solution that you have built for yourself, or you use a third party library for that state management. And then a common example of it, especially for Angular apps, is NGRX library. So then the NGRX library setup is what is the way that all of your components will use to receive or send data. You can also have a web worker, IndexedDB, and like I said, we really don't have the time to go in depth into all of these, but there are a lot of ways that you can be sharing data. That is all I have for you today. Thank you so much for your time and attention, and for letting me come here and talk about all the different ways about sharing data. If there are any questions or anything, I'll be happy to, any comments, I'll be happy to take them now.
Thank you, Anikita, for really inspiring presentation. It's straightforward. The information and knowledge is really clear, and it's really inspiring. Really, I enjoyed in it,
Yeah.
especially the audience. Really, they are inspiring, and for sure, they're enjoying this presentation. Uh, all the knowledge, it's really inspiring and really good and clear. And the most thing I'm interested in it, how to pass data between parent and child.
Mm-hmm.
Yeah, you describe it like really easy, and it's really clear how it's sharing between child and the parent, and how pass uh, between parent and child, and in the reverse way from child to parent. I want to ask two questions
Mm-hmm.
actually.
Mm-hmm.
um, how do you ensure optimal performance when dealing with large data set in Angular component?
when you're sharing a large data set.
Yeah.
Yeah, I think Angular usually takes care of performance. What you want to do is share immutable data most of the times, but just by sharing data, your performance is not going to be impacted. And you can, it's just how if you use change detection on push specifically, that is something that you can add in a component that would also take care of performance. So I mean, sharing data does not impact the performance as much. It depends on what you're gonna do with the data. So not
Mhm.
just the sharing aspect of it won't impact performance.
Okay, okay. Um, as your experience and um, you been through a lot of developer, and you see a lot of progress between these developer. I want to ask you, what are the some common fault developer face when implement data sharing in Angular, uh, and how can they be avoid?
How can some common pitfalls?
Yeah, yeah, yeah.
Um, well, while you're sharing data, sometimes you would not. Um, let's see, maybe you're not sending it in a type safe way. So because Angular uses TypeScript, you can make sure that all the components that will be, like, for example, for in a child component, you can make sure that it is type safe so that you're not trying to share something that is not supported by the child component already. So
Mhm.
and then you can similarly you can have types defined in the parent and styles defined in the child, so it just avoids compilation errors. For input properties also, you can mark them as required if you are if that's something that the child component absolutely needs. So then it also prevents, it will throw an error at compilation if the parent isn't passing them. So then it just becomes more, like more, it becomes less error prone. So yeah.
Okay, thank you so much. We will wait for like if anyone want to ask, please write your question and comment, um, and we will try to answer it.
Okay.
Okay, Nikita, again, thank you so much. I know
Yeah,
you.
here.
Yeah, we've been through a lot of preparation for this
Mhm.
session, and you are very, very helpful person. Direct answer the emails and try your best to give us the clear message, clear information. Uh, I'm really for my personally and for GDG Agabe. We are so glad to have you. Thank
Thank
you so
you. Yeah,
much. Thank
my
you for the
pleasure.
information. Yeah, you shared with me on the email about the Angular and the TypeScript. It's really, really helpful. And thank you so much. And we have, yeah, very happy to have you again here in GDG Agabe.
My pleasure. Yeah, thanks for having me.
Thank you so much.
Okay,
Bye.
thanks, bye.